Yo, 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 yo. Hello, everyone. Welcome to another episode of Bitcoin Developers. Thanks for joining us today. So we've got another episode with my friend Jeff here. How's it going, Jeff?
Hey Connor, what's up?
You all right, yeah? You
I don't
good?
know, right? Yeah. Saw a black cat cross my path this morning, so I'm not sure if that's a good or bad omen for our team, but
No,
see how this goes today.
I think we'll be all right. Shout out to the people in the chat. What's going on? Where are you guys tuning in from in the chat? Give us let us know. Let us know where you're tuning in from. I see 11 people in the chat at the minute. Good to have you. Yeah, so today we're gonna have another episode about how we can help you become a better Bitcoin developer. Today's episode is based on the Lightning Development Kit, which some of you might have heard about, and we're gonna explain to you why it's such an important project in the Bitcoin space. LA ATL, nice. LA, awesome. So we'll explain a little bit about what that's all about in a moment. But Jeff, do you want to give the audience a little introduction about yourself? Like you're a Bitcoin developer. What's your background? How did you kind of go down the rabbit hole, and where did it kind of all start for you?
Yeah, that's a good question. So when I was, I guess, still in college, I kind of started thinking about money and realizing I didn't have much of it, and why the value kept on depreciating over time. And uh, after some journeys down different rabbit holes, I came across some of the hard money camps and Austrian economics, and um, when Bitcoin finally came on the scene, I kind of wrote it off, honestly, and I didn't think it. I just always thought of it as like, oh, it's not hard, it doesn't exist, it's not tangible. How can this be money? And then, um, after some more study, I'm like, okay, I kind of understand this now, and just kind of went down the rabbit hole. But I never really had an opportunity to develop with Bitcoin or on Bitcoin for a number of years after that. I was at a big tech company for 10 years. And, as kind of the world kept pushing forward and seeing, inflation tick up, and
Mm-hmm.
I was, I realized I wanted to do something in my sort of day to day that was more meaningful, and Bitcoin was
Mm-hmm.
always sort of there in the waiting for me. So after I decided to leave my employer, I found Spiral at the time, called Square Crypto, and been there since the last 2+ years now. So working on the
Okay.
Lightning Development Kit.
Awesome. So you was at the organization from its very inception. Awesome. Do you remember like so just back to like the Bitcoin story a little bit? Do you remember your first Bitcoin transaction or?
um, Let me think. I definitely was playing with the blockchain.info wallet for a long time. This was,
Ah.
it was probably around when Coinbase was just coming about, Mt. Gox was collapsing, and I didn't know, where to, safely store my funds. So I was very much a newbie in that regard.
Okay.
Um, Eventually, I got, I think, a hardware wallet, a ledger. So I started using that and really getting
Mhm.
into the security side of things. And
Nice.
yeah, I've been sort of playing with different like multi-signature setups these days, and
Awesome.
doing everything I can to learn more.
Okay. Awesome. All right. So we're gonna talk a bit today and do some live coding around something called the Lightning Development Kit. Let me just share my screen here while we talk about it. If I share this one. So do you want to maybe like give the people a little brief intro into just like what the Lightning Dev Kit's all about? So in our previous episodes, we have had 2 episodes about the Bitcoin Development Kit with Raj and Thunder Biscuit. And we did some live coding and programming around that. How does Lightning Dev Kit maybe differ to that, and maybe what are the similarities?
Mhm. Yeah, so I guess at a real high level, people have probably heard of a development kit in the terms of an SDK, and that's typically some sort of interface that is available for a developer to use. So, for instance, like Java has an SDK. I think they actually call it maybe even the JDK the Java development kit, and it provides a lot of basic functionality for using the Java language. So you think about like database connections and networking I/O and all sorts of maybe even very small primitive sort of classes and code constructs. For Lightning, we want to do something very similar. We wanted to have a way for someone to implement or I should say add Lightning to their wallet or application in such a way where it kind of abstracts away the details of the Lightning Network protocol, because it's pretty complex, and there's a number of implementations nowadays. So I guess what you could think of this as a some sort of like software library that implements the Lightning Network protocol for you, so you don't have to. But it's done in a very flexible, sort of customizable manner where, actually, so for instance, like we don't even provide a network stack for you. We have some auxiliary utility, I guess some utility parts to get that does it for certain languages. But if you want to bring your own way of reading and writing from the network, that's up to you. And so you can do it whatever way is best for your product. Likewise, if a big part of Lightning is saving channel state, and well, you might be able to store it on disk for like your first round of developing your application. You probably want something more robust for a production setup, where you have like a multiple backups. You might have some data stored in the cloud and also on your phone. So it really provides that sort of flexibility for you to do whatever is best for your product. And likewise with the wallet and signing, like you could bring your own wallet, and it could be a really integrated experience for your user. And you don't have to have, say, a Bitcoin wallet separate from a Lightning wallet. You could use be one and the same. And so we just want to provide the developer with the most flexibility as possible, while at the same time sort of abstracting away the Lightning protocol.
Okay, awesome. And obviously this is all like open source stuff. And you mentioned that you're working with myself over at Spiral. So our team is, I guess in some regards, like leading the charge on this effort. But it's by no means doesn't mean like we have a lot of external contributions as well. So just like a quick glance at the GitHub repo, I think we've linked to it in the chat. There are a number of different repos that you can have a look at and kind of dive into. So the core repo, which is LDK, but it's called Rust Lightning, to add a little bit of confusion there, because it was originally, I guess, created by Matt Corrala, who's also in our team.
Matt and also Antoine Riard were the two main developers early on. Antoine is one of the Bitcoin Core developers too. I mean, Rust is like, it's a very secure language and similar to, or it provides some of the similar characteristics of C as far as what sort of like low-level programming you could do. So it's a good sort of base for Lightning development kit. And I see a question in the chat here about having some like default modules to swap in and out, and we do provide some. So like, for instance, this Lightning Net Tokyo is an implementation of the network stack using Rust, and so that could be sort of plugged in and swapped out, if you would, to the interface we use for in the main Lightning crates. So these crates are sort of the terminology used in Rust, where it's sort of the way to subdivide your repository. And so each crate has its own set of documentation, but you could think of the Lightning one on top there being sort of the main implementation of the Lightning Network protocol. And from there, you can plug in all sorts of different things and swap things in and out. So yes, it is correct. We do have some implementations of say, the network stack and that Lightning block sync crate. And there's other ones there. There's Lightning Net Tokyo, I misspoke there, is for the network stack. Today we'll probably be touching a little bit on another one called the Lightning block sync. And so there's
Lightning Net Tokyo as well. We need to have a little.
So there's quite a few, and Lightning Persister is one for what you use to store your data elsewhere. So we provide a one that just writes the file system in that crate, and then that can be swapped in and out.
Okay, and the other thing that is important to mention as well is this idea of language bindings as well. So
Yeah,
the
exactly.
idea that developers can kind of develop in their their programming language of choice. Do you want to touch on that a little bit as well?
Yeah, totally. So, like I said before, Rust is what we're using sort of as the base for this very secure implementation of the Lightning protocol. But on top of that, we can sort of let the user write in the language that they're choosing by having this binding. So, a binding is a way essentially to allow you to write in that language. So, for instance, if you go back to that page there you had up, we have this Lightning garbage collected. We have Lightning Swift. I believe there's Lightning C bindings. So essentially, what we do is we are generating C bindings that sort of bridge the gap between Rust and your language of choice. So that LDK C bindings is like basically the basis of what does that bridge. And then from that, we have stuff like the Java bindings, or sorry, it's called. Right. We used
Garbage
to go back one
collected.
page. Yeah, garbage collected, I believe. From that, we could build other languages. So, like for instance, Java or Kotlin is something that we already have in there that is being used by a couple of organizations now. Blue Wallet and Cache, I believe, Cache App. And then, we don't have every single language just yet, but from this, you could actually build your own bindings for, say, Golang, and then I believe maybe TypeScript. Yeah, so we actually have TypeScript in the works right now. It's very alpha, but it seems to be less work than we thought. So we're hoping to have that stabilized in the coming weeks and months.
Awesome, cool. So that I mean that just opens I guess Lightning as a platform for like so many different use cases, like mobile, both on Android and iOS, more enterprise-based solutions because we're using a language like Rust and C and support for Java as well. And so that's awesome stuff. So where can if people want to follow you and stuff, like is like Twitter a good place to connect with you and stuff like that?
Yeah, I don't tweet very much, but the username that's up there, JKCCYZ, is my Twitter handle, and maybe I'll start tweeting a little bit more about what I've been doing with Rust Lightning. Currently, I have I'm working on probabilistic channel scoring, which is basically a way to do some better pathfinding and for routing payments in Lightning. And I'm looking forward to getting that merge hopefully this week, and then push out to the next release. So it's gonna be fun.
All right, cool. All right, so we're going to dive into it to one or two things today. So you mentioned this concept of like crates and modules, and one of those crates or modules gives us the ability to interact and be notified of different things that are happening on the blockchain. Lightning, just generally speaking, is very much like anchored to the Bitcoin blockchain. So we need ways to interact with it and get information from it and that kind of stuff. So today we're going to look at one of those ways of sourcing Bitcoin blockchain data, and how it kind of like interacts with some Lightning aspects as well. So before we dive in, do you maybe want to talk a little bit high level about like that module in the LDK and some of the flexibility that particular module has?
Yeah. So just a little background. So when I mentioned before that we have different ways to customize different aspects of Lightning here. How you store channel data, for instance, how the network stack is implemented. We also have the same for how blockchain data is sort of fed into the system. So if you want to use a full node, if you want to use maybe an Electrum client, maybe you're using compact block filters, there's a ton of flexibility there. So today we're going to talk a bit about a way to feed full blocks into the system. So Connor has on the screen here I guess a pared down architecture of LDK. So this is talking about some aspects we'll be covering today. So Lightning Network Tokyo is the networking one that I mentioned, but to the right of that, on top in the blue box there is Lightning Block Sync, and this is essentially, it defines a couple key components. So one is a SVV client, so a simple payment verification client, that is sort of parameterized by a block source, and that's what we'll kind of walk through today. And the idea here is that this client can pull that block source for new blocks. We'll ask basically if there's a new header and do some basic checks, and then compare it to what it knows about. From then, it will fetch a block and feed it into LDK. So that's essentially the high-level view of what's going on here. And it handles a few things like that are important. So I mentioned as some basic verification that the blocks that you are feeding into it, or that it's getting from the block source, are actually conforming to having the most work, and that if you're make sure you're building on top of blocks you've already seen, and also it handles like reorg detection. So if a block gets reorged out of the chain, it's going to make sure it finds the common point of where a new block came in, and sort of disconnect blocks for you, and then reconnect blocks back that you see. So it's pretty smart about that. It does a lot of work for you. So we'll kind of walk through that today.
Okay, that sounds awesome. Right, so let me kind of change into pair programming view, get my code editor up, initiate a project, and all of that good stuff. How are we doing in the chat? Any questions so far in the chat before we kind of like dive straight in? We will be programming in Rust today, so you have to forgive me sometimes for my lack of Rust knowledge, but we have the expert Jeff here to kind of help us along.
I'll do my best. And one thing to note on those docs that you have on the screen there, I think there's a link in the chat. There's a note on, I think, towards the top of the docs about different features you could build this crate with, and it enables or disables basically RPC and REST clients. And unfortunately, our docs aren't built with those features enabled. So some of the code, this RPC client in particular that we'll talk about today, is not in those docs, but we'll try to fix that in the future releases.
Okay, sounds good. All right, so let's see how we go on. So okay, so I'm gonna hide this for a second and open up my terminal and try and initiate a project here. So I'll go into my projects folder and let's create a directory called block sync LDK. I don't know, let's call it that. CD into that. Whoops. So yeah, I think to initiate a new Rust project, it's cargo new, and then name of the project. Call it the same thing.
That might make you another directory, but I'm not positive. It's been a while since I've typed cargo new.
Yeah, it does. I've kind of double whammied it there, but no problem. We can seed into that, and then let's open it in VS Code and see what it shows us. Okay. So, all right. So we've got a brand new Rust project here, and it's automatically generated just a main function for us, some Git stuff, and then our cargo file for our dependencies. So this might be a good place to just start and help people understand like how to import LDK and like what specific modules they need to include.
Yeah, so the main two that we'll deal with today are the Lightning crate and the Lightning Block Sync crate. So let's kind of talk through that. So I guess you're probably a little more. Yeah, I got all these cool autocompletes. Look at this. And
yeah,
so,
no. Well, you should have seen last week, man, when I was doing Kotlin and the BDK. Like I was literally type in like 2 letters and it was just auto completing. I was like, I feel like an absolute expert right now. But VS Code is not as smart as Android Studio, unfortunately. So we all have to do a little bit of stuff here.
Gotcha. Yeah.
So
So
the path we have to include is the
yeah, I
link
think
to.
it depends on, and so here the dependencies are can be done in a couple different ways. One, you could point to a particular version of Lightning, and that will sort of pull it from, I think it's crates.io. I forget exactly where it is, but or you could point to essentially a version you have in your client.
All right, so
or you can even do both.
Okay, so one is like literally like a version.
Yep.
And it was 0.0.104, I think it was the latest version.
That's the one. And then also a path, which would essentially,
And then a path.
be a way to I guess get code from your
Can you
local.
also?
And yeah, I think you need equal signs and not colons.
Oh yeah.
That'd be one thing.
Can you also get it from Git directly as well? So
yeah, there's a couple different ways. I guess the best bet would be to, if you're interested in doing that, to search for cargo dependencies, and there's a whole guide about how to do those. But yeah, you could also do it to Git.
Okay, so
the path is the other one you mentioned, and that also depends on like where if you have the Lightning or the Rust Lightning project somewhere, you'll be able to locate it this way. I'm not sure what your setup is like.
Okay, so I don't. So I want to point directly to cargo, something.
The version is fine. I think that's all you need is just the version there, and you should remove the path if you're not. And then this should, if I.
Okay, so VS Code is actually clever enough as well to give me like a what extension am I running? I'm running. Let me just double check the extension. It's called what is it called again? No, that's, how do I check my already installed one? So I've got Rust Analyzer tab 9.
That's pretty nice for autocomplete there. I wonder if
I think it's crates. I think it's called crates actually.
There you go. Yeah, that might be it.
So yeah, it will automatically detect if like you're not on the latest version either. So I don't know if I do like 102, it gives me like this little X that you're not on the latest version, which is quite nice, I guess. So all right, so Lightning, we've imported the main Lightning crate. What else do we need?
So we'll probably want the Lightning block sync crate, which also it does have a dependency on Lightning. I think we'll be using both of them independently. So you do need both of these, and I believe that should have the same version, if I remember correctly. We're sort of gearing up to 0.1 release, so the next version forward would be like kind of like release candidates for something we're happy with people using.
Cool. All right, cool. So we've got Lightning block sync. Is there anything else that we need off the top of our heads?
Yeah, those features that I mentioned were something that would be important. So earlier I mentioned that some of the docs weren't showing up correctly because we weren't enabling certain features. So I'm just gonna find some place where we do this. I believe in our LDK sample node, we have ways that, you're at a features sort of attribute to this Lightning block sync.
All right, so we need a features attribute, and this looks like
this will be a list. So it'll be
this will be a list. Okay.
Yeah, a list of strings where we wanted to include RPC-client as the feature.
Got you. So okay, so features. How would you describe features? So you have like a crate, and then you have like you can explicitly. So if you don't explicitly decide what features you want to use, will it just give you all the things, or?
So I believe there's ways to structure your cargo file to do that. The way we have it now is that that you have to enable these explicitly. So for instance, here we have there's I believe two features in this crate. There's RPC client and REST client, and if either of those are enabled, it essentially is including more code in this crate.
Got you.
And if they're disabled, then it would not be included. So that's kind of why the docs don't have all the code we'll talk about today, because we're going to enable this RPC client feature. But for those following along, you want to kind of go to the repo for this Lightning Block Sync. You'll find a rpc.rs file in the Lightning Block Sync crate for this particular file.
Okay, that sounds good. So we have our dependencies. Is that everything? Do we need to import anything else?
I think that's all we need. Let's see how it goes.
Okay, let's see how it goes. All right, so we have our RPC client feature imported. Let's just go back to our directory and have a look again. All right, so we've got like our main RS. So I guess here we'll do, eventually what we want to do is instantiate a RPC client, give it the required parameters that allow you to connect to a Bitcoin core instance running locally. And then from there we can like start polling for different like chain activity by auto generating some blocks and that kind of stuff.
Yeah, totally.
All right, that sounds like a plan. So what's the best way to maybe break this out? Should we like create a separate file for our Bitcoin D client and start implementing things that way?
Yeah, that could work. I think it's up to you.
Yeah.
We could,
Okay.
it's a good way to sort of break this up a bit.
Yeah. All right. So we'll have like a Bitcoin D client.rs. Cool. So what's this is one way we can like implement a client for Bitcoin D, right? Like there's multiple ways that this could potentially be done. We're just kind of going off some samples that we've used in the past, and it's pretty quick and easy to understand.
Yeah, the Bitcoin D has both a REST and RPC interface that allows you to interact with it, and that's it's one way to sort of grab blocks from a running node and essentially feed them into LDK. But yeah, there's multiple ways you could do this. This is the one we'll look at today.
Okay, cool. So in order to connect to a Bitcoin D instance, like there's a few things I guess that we need, including like the host, the port we want to connect to, like username and password and all that kind of stuff. Should we define that in like a struct or something, and then
yeah.
Okay,
so maybe what we could do is we could define a different struct, or there's different ways, I suppose. One, you'll need the host import. You'll need sort of like a username, password pair. These are things that like your application could read from the user. They could pass through a command line argument. It's really up to them.
I got you. Okay, so we can do something like this then. So we'll have like a Bitcoin D client, and some of the stuff that you just mentioned is that Lightning Block Sync comes with an RPC client which we imported. So if we have a let's see, if we have a Bitcoin D RPC client of that type, so it's saying I can import. So we have like this is it RPC client?
Yeah, it's called RPC client, and this is not sure if it'll put the import for you there, but it should be from the Lightning Block Sync crate.
Okay, so let's see if it automatically, if VS Code is smart enough to pick that up. Mod Bitcoin D client insert. No, I don't think it is.
It doesn't look like it's. I think you would want to import this from, but I'm not sure if this would automatically.
Okay, so if I don't think it does. I don't think VS Code is actually smart enough. So we can import our RPC client like this.
Yep.
Okay, cool. And then we'll have some other some other properties as well, such as like, we'll say we're going to pass in a host, which would just be our local host, a port, a port, what else do we want? A username, I guess.
Yeah, and some of these parameters we're talking about here could be parameters to like a new function that are just simply passed along to this RPC client as well. If you need them later, it's a good idea to store them, but otherwise might be fine this way.
So okay, I think is that everything we probably need for to connect to a Bitcoin node, I think, right?
Yeah, I think that should be about it.
Yeah, I think that's about it. Okay. And then next we have this idea of like a block source trait. So maybe we go over to the docs and have a quick look at this idea of where are we? A block source. So explain a little bit about like what this is. So this is a trait that provides us some methods that we can implement in a custom way, right?
Yeah, so traits are kind of like, if people are familiar with other languages, they're kind of like interfaces. So if you have a struct, you can implement a trait by defining these particular methods. And the one we're looking at here is about a block source. So it defines or declares, I guess, 3 methods or functions that you need to define: get header, get block, and get best block. And so the way this is used in our SPV client is that it will pull one of these block sources by calling get best block. It will take the header that's essentially returned, or sorry, it doesn't return, it's a hash rather that's returning. The block hash is returned along with potentially a height if it's known by this block source of where it is. It will compare that against what this SPV client knows as the most recent best block. And if it's basically higher in height, it will sort of start fetching blocks by looking at the previous block, getting the header, etc., until it finds all the blocks it needs, and it'll fetch them one by one with get block, or all the headers it needs. And so this interface is asynchronous. So you see this async block source resolved. It's sort of hiding some of the specifics of asynchronous programming in Rust, which is its own separate crate, this Tokyo, and some other futures-based programming. So what you could think of these as are methods that return futures, which are sort of executed and awaited upon. And that's the way we could sort of still have the user interact with their program while we're waiting on data from the network in a very idiomatic Rust way.
Okay, that makes sense. So we can use this like default implementation and then customize what we want from each method. So
yeah, and just one thing to note is that that block source crate, or sorry, trait, the block source trait is, I believe, implemented by this RPC client. But since we want to do other things with this client, would like say.
Oh, okay. So say that again. So this interface, this trait is implemented by the RPC client already, yeah?
Yeah, I believe so. Let me actually verify that. I could be mistaken. Oh, actually, no, I might be mistaken on that. I think we'll just be implementing it today.
Okay.
But I'll double check while you kind of go forward.
Yeah, no problem. Okay, so we need to implement these methods somehow. So if I remember in Rust correctly, it's like you want to implement a block source, and then for our Bitcoin D client. Okay, so block source is a trait from Lightning Block Sync. So I'm assuming we'd have to import that as well, right?
Yeah, correct. And I don't think you need the ampersand on block D client because that's saying you're linked for a reference to a Bitcoin D client.
Okay. I'm just looking at how to import. So, yeah, VS Code is not being as friendly as it usually is. Usually, it will just like auto import it for me. But
yeah,
I guess it's like
similar to that one.
yeah. So
I
I
believe
guess it's
it's
just like this way. And then
I think block source is right at the top level. So I think if you just do it from there,
so
should
do that. Okay. Source. Okay, cool. And then okay, so then we had these methods, right, that we need to implement. Function get header. So I could probably just copy these from here, right?
Yeah.
It returns an async block result.
I was looking at the code, and yes, we do implement block source for our PC client. And if you see some of the other code that I think it's in our sample application that uses this RPC client, it's essentially doing something similar to what you're doing right now, and you're wrapping it and delegating to that to make these calls. And that allows you to use this RPC client for other things. You may want to just make sure that when you connect the chain you're connecting to is the main mainnet chain, and then test versus testnet or vice versa. So it's just a nice way to still be able to use the Bitcoin D client for other things.
Got you.
Or this RPC client for other things, yeah.
Okay, so we'll do like our implementation in here, basically.
I think what you can do is in Rust, there's this nice macro called just unimplement it. So if you say unimplement it, then exclamation point, and I think you might need two parentheses
so
after
is it as a comment? So
not a comment, just for the code. If you type in unimplement it,
implemented.
Yeah, then I think you've got the two parentheses after that, opening, closing. And that way you could actually compile, once you have all three of these filled out, that way you could compile and not get syntax errors. Because you need return types for some of these, and it gets a little complicated.
I think as well, the reason syntax highlighting is not working is because I've not built it yet. So let me just run let me just run the program and just so it builds everything. And let's see if we get any errors. Okay, compiling Lightning version 104.
Cross your fingers.
Yeah. I think this will make our life easy as well. I forgot to do that at the start, but once we get this, it should give us like auto suggestions and stuff. But let's have a look.
All right, there you go. All right, so now maybe we could try going to the main function and instantiating an instance of the struct that we had defined.
Hold on, I'm just so question. Did you include the Bitcoin D client module in the main? I don't think we did.
So not yet. That'll be the next step. And I think Rust was smart enough to at least build that and make sure it's compiled, but probably stripped it out of the final binary.
So we could just including it like this, right? So we could do Bitcoin. I called it RPC client. Is that what I called it?
I think you could just let's see.
Just okay. All right, there we go. That's what I was looking for. Right.
Okay.
So
I got it in front of a lot of hashes. I guess the user or the commenter always correct. We probably didn't build that since it wasn't included there. And so
okay. So this is what I was looking for. So I could just like automatically import stuff. So block hash no code. Okay. Right, so yeah, I was looking for something like this basically. So if you just at least in VS Code anyway, if you command click, you can auto import stuff.
Great. Yeah, thanks for the comment, Bay. I think it's not mandatory if I'm pronouncing that correctly.
Yeah, thank you. Block hash. Where's block hash coming from then?
So this will be, I guess now we'll need to have a dependency on the Bitcoin, Rust Bitcoin crate. So I think we'll have to go to back to our cargo file and make sure that's important too.
Okay, cool. And that's Rust Bitcoin.
Yeah, so this is a sort of a sibling project to us, and it's been around for quite a while. I'm going to look up the most recent version we've been using on that.
So Rust Bitcoin. Have I lost the stream again? We're having problems streaming. Why does this keep happening? It's annoying. We'll be back on in a second. Okay, so I'm in cargo. I'm trying to look for Rust Bitcoin.
So it's just Bitcoin, but it's
it's just Bitcoin. Okay.
Yeah, the Rust Bitcoin is the tag for the repo, but in the cargo it's just Bitcoin. And,
so it is this one 0.27.1. Okay.
Yeah, it should. Yeah, we're using 0.27, so that should work.
0.27.1. Oh, and it's just Bitcoin. I've called it Rust
Bitcoin. Yeah, just Bitcoin. Sorry about that.
Let me just have a look in the chat again. Are we still live? Because I was getting a message saying we've kind of dropped off. Hopefully, give me a thumbs up if we're still live, guys. So this block hash comes from Bitcoin block hash. Got you. So now that we can auto import that, and I guess block comes from there as well. Yeah,
and likewise with block. So we could walk through some of these methods a little closer. So we have we have some warnings because we're probably not using those just yet.
Yeah,
that's fine.
That's the only thing. Okay, we're still live. That's the only thing when you allow the code editor to do all this stuff. It's very shouty, isn't it? It's a bit annoying, but.
So get best block is returning, like I mentioned before, the block hash of the best block of the chain that you're querying, and optionally is a height for that block. And so we'll make sure to implement that. And then get block and get header are kind of similar. I mean, right now get block is returning a block, which is defined in the Rust Bitcoin repo. So this Bitcoin crate, and block header data is the return value of the get header, and that kind of gives some extra data that we want. We don't just want the header, but we also want, I believe, the height. And I don't know if you could jump to that code, or if not, I could look it up. But there's
so what's this for? So for block hash.
Block header data. Block header data. It's under get header.
Yeah. So we can jump to the definition here.
Yeah. So okay, we got the header, we got the height, and then also the chain work. So we're making sure we're actually on the heaviest chain.
Okay.
So the Lightning block sync crate will handle this for you. That's the nice thing about it.
Okay. All right. So let's try and do some basic implementation for these methods then. The first one being the get header. What does what might an implementation look like for this?
So here we're delegating to our RPC client, which again is defined in Lightning block sync crate, in which we've included as a member field, I guess, or field rather, to this Bitcoin D client. So up on top of the file, you use that. And it has, so we could jump to that code maybe for a minute and just see how it's, what sort of interface it defines for us to use. So some of the same things we mentioned, this basic authentication is essentially the username and password. Endpoint, you think of that as the host and port. And under the hood, there's this HTTP client, which is used both by the Rust and the RPC client to implement this. And I can't recall what the ID is for. I think it's something to do with the when we send RPCs to Bitcoin Core, we use or increment that different ways. So there's a way to construct this with the new. So you handed the credentials, basically. These are your username and password.
I see.
The docs sort of define how those should be passed to it. we have this call method, which is it's a generic method, so it has a type parameter to it, t. And essentially what that does is it's a way to make RPC calls using this sort of JSON format to your Git20 full node in such a way where you could say, okay, I want to get a block, or I want to get a header or the best block. And you do that by essentially, well, this crate does that by defining particular types that it could be used within this call method parameter there, that type parameter. And what that does is it takes the return JSON string, which is actually this JSON response, and it converts it to a struct that sort of breaks out all those fields. So you could maybe program it in such a way where you're not thinking about raw JSON and trying to navigate through different I guess the structure of JSON, but instead you get something that we are positive that it conforms to the interface of, say, get block RPC call.
Okay, that makes, and if we didn't do that, we'd have to like implement different.
Yeah, you have to parse it on your own.
Yeah,
make sure all the everything is included when it should be, and if it's not, return error. So this is kind of like a very handy way of just doing that for you. And if you happen to want to make more RPC calls to then the three that are implemented in this RPC clients, you can define your own and your own types that essentially are used to store the data that's returned in the RPC or the JSON data in more of like a Rust struct. So we could jump over to some of those if you want, or we use, I don't know, for time's sake, maybe we just continue on.
Yeah, so yeah, let's continue on for time's sake. Got about 45 minutes left roughly. So let's implement our first function, and then maybe use some sample code for the other two. So what do we do for get header?
So there's two things we'll be interested in here. One is that we want to make sure we're using this asynchronous interface correctly. So that async block source results are hiding a lot of the magic around Rust's async code. And then two, we want to delegate to our RPC client to make the call that we're interested in to get that header.
Okay.
So let's
so
see.
The asynchronous stuff, there's how do we handle that first?
Yeah, this is some of the stuff I always have to find a reference to since I don't use it much. But if you want to jump to that async block source results type, we'll see how that's like a type definition. So the alias for it's something that's pinned to a box of a future that could be any type of future essentially. So futures is something that can be executed sort of in the background, and you wait on it.
Right. This reminds me a little bit of like JavaScript async await type of thing.
Yep, all that. It's very similar concepts. Box is a smart pointer. You can think of this as, like, if you're familiar with like C++, it's a unique pointer. So once this goes out of scope, the data is cleaned up. And pin, I believe, is a way to say, I'm probably gonna not get this 100% correct, but it's a way to say this can no longer be moved. So at Rust, there's these move semantics, which allows you to sort of move data around instead of copying it. And when you're talking about asynchronous code, you want to make sure that threads are playing nicely together.
Okay, all right, that makes sense. And then okay, so then you said next we want to use our RPC client to make those RPC calls. So can we just create use that instance here? So if we have like our RPC equal to self.
Yeah, so let's see, I think so there'll be two things you want to do here. One is sort of form whatever parameters you want to this RPC client, and then return that correctly, or return that to, I guess,
This function,
from
yeah.
this function, yeah. So
Right. So do we need to like? Is there so async? Is there like an await part of this equation here? So
that
the
will
async
come
code is
towards
saying
the
wait.
end.
Oh, I
Yeah,
see. Okay.
yeah. So let's just remove the let mute RPC from the start and just say self dot Bitcoin
Okay.
RPC client, because we'll fill this in as
Okay.
we go. But so
Okay.
we want
Okay.
to make a call. We're going to do a call method.
Let's see. So get rid of this.
No, that's good. That's good how you had it. So
Okay.
you're basically delegating to this RPC client, and then
Okay.
you're
And then
saying dot call, like an actual method is called call
I see.
method because it's calling an RPC method.
Got you. Got
And
you.
so this is like part of the Bitcoin D JSON RPC interface. And
Mm-hmm.
so get block header is all one word, lowercase, and is a string is what we'll use. That's the method. So this is just interfacing essentially with the Bitcoin D client. And then that takes parameters. So, we're
So
provided
we're gonna give it the header hash and height hint, I'm assuming.
yeah. So
Got you.
I think our height hint we won't need for a full node client like this. So that's
Okay.
something we won't need in this. But the hash we will need.
So we can just pass in header hash like that, I guess.
Yeah. So this is where we'll start getting some type errors because this call method interface takes I believe it's called a JSON object. And
Okay.
this is where we'll need another dependency. So this is, maybe if we jump to that call method again, we could see what we're looking at.
Okay.
So there we go. It says it's taking basically this is a slice. So you can think of it as like a portion of a list or a vector array of these 30 JSON values. So these are just JSON values that can be serialized and deserialized. That's what the 30 crate is, so 30 JSON. So I think we'll need to import these as well, or have the dependencies for these in our cargo file for that one.
Okay, so it's what is it?
So I'm gonna look
Dash
this up.
JSON.
Yeah, serde_JSON. You can just do version 1.
Version 1.
1.0. And there's optional equals true in the reference I have. I'm not sure what that one is for, but I think we'll see if we need it later.
Of course I need to do version 1. Oh, it's _JSON as well.
Yeah, underscore. There we go.
Okay, cool. All right. Okay, nice.
And that provides those I guess JSON representations, and we'll want to take our header hash that's passed in to get header, and we want to basically convert that into something that's more of a JSON representation that our Bitcoin D client understands through this RPC interface.
Okay. So do I need to import something from JSON in here first, or?
Yeah, I believe so. I need to find that reference.
Okay. While you're doing that, any questions in the chat so far? We're doing like quite a lot of like boilerplate stuff right now.
Yeah.
Feel free to like answer any questions you might have. We're kind of diving into the weeds quite a bit here. So if you have any questions, feel free to shout out. Let's see, sir.json.
So I think if you just use serde_JSON, we'll do that, and so you can just put it at the top. If you
import for me,
because that will give us the entire crate, and then we could just reference it from that. So at the top, if you use serde_JSON, you don't have to, you just put a semicolon instead of anything else after that. Just remove those colons and put a semicolon. And so now we could use that, and we could say something like, let's see if I could find it. There it is. Okay, so the serde_JSON, if you do that, then : And then JSON exclamation point. This is a macro under all lowercase. Yeah, there you go. And if we do header hash dot hex, because that's the format that this Git block header is going to want, this will be with lowercase, and it'll be a string. So a string called, oh, sorry, no, you're right. Header hash dot,
because it's the parameter we're passing in, right?
Yeah, sorry.
Yeah.
Header hash dot or 2 hex, 2 underscore hex. And I think this will probably need another underscore hex. Yeah, 2 underscore hex. There you go. And we may need to include these errors are saying. Oh yeah, I think we'll need a reference. So it's let's see. In your params, I think you want a ampersand before the opening bracket of before if go back to, or sorry, where in the code itself, the implementation there, you have right there. So before that, yeah. So this is a slice. There you go.
Okay,
let's see what else it's complaining about.
Future.
Okay, so type mismatch. So now we want to do our, so basically this is saying that, okay, this thing returns a future, but we want this sort of async result type. So this is, we're going to get into some sort of conversion from different types in Rust. So at the end of the call to call method, so at the end of that parenthesis, let's see where you are. Right. If you do dot await.
Oh, so yeah, because this that was the bit I was waiting for, like the await portion of this whole async thing. Okay.
Yeah, since that returned a future, and then okay, so now there's a little bit more things we need to do. So that returns some sort of result,
right?
And if we put if it's a question mark, which will essentially, it's a nice little Rust syntax that says, if this is okay, then just grab the value inside the result. If not, if it's an error, we're going to return that error. And then one last thing is, since this is this async block source results, when we looked at the alias earlier, it's actually a result type. So we need to wrap this with an OK as well. That's
yeah. So a future returns an OK, or what was the other one?
Yeah,
or an error.
Yeah. So this is kind of do some converting of errors and results, basically result types. So there we go. And then since we're not using,
if we wanted to, we can just we could return an error of something.
Yeah.
Do we want to do that as well? Or?
No. So that question mark that we put in there, what that will do is that if that's an error, it will return for us essentially.
Got you. Okay.
And let's see, what does it say here? Okay, there we
no,
go.
I think that's it. Yeah, good. Okay.
And then height hint we aren't using in this particular implementation, so we could put it underscore. We can name it height hint, we'll put underscore at the start, and that will essentially get rid of that warning. There we go.
Cool. All right. So just to recap then, so we have basically used our RPC client call method to make the core RPC method call, which is get block header, with the parameters, with the parameter that we're going to pass in, which is just a header hash in this case. And it responds with a header hash in hexadecimal format.
Yeah, it's basically saying I want the header that has this hash. So we are taking the block hash, we are converting into a JSON representation. We are making a call to get block header with that representation of the block hash as a parameter, and it's returning the associated block header for that hash.
Okay. All right. So what we could do then is it essential we have these other methods to use get header? We don't necessarily need these, or is it a condition that you have to implement get block and get best block in order to?
So we'll have to implement both of those. I mean, we could still compile without this. I'm not sure if you want to take a step to do that, but yeah, we'll need both of these. So essentially, the idea is this SPV client will use get best block to try to find out what the best block is from your block source. It compares with the knowledge it knows about the chain up to that point. And based on that, it will call a git header and potentially git block after that as needed.
Okay, that makes sense to me. So it's very much the same then, right? We can pretty much copy and paste this into the next two and just call the relevant RPC methods for each one, right?
Essentially, like there's be two differences. One is the method, so that string we have, get block header will be different. And then also the parameters will be different. So some of these parameters might get a little long. So what we may eventually want to do is make a local variable for the params and this pass them in that way. But it's up to you how you want to do that. Because I think,
we're going messy. We're going messy with these tutorials. So like no worries there. With regards to making things look pretty, it's kind of just
make it work first and then clean it up later.
Yeah, exactly. All right. So this is get block. So is that just a get block method then?
Yep.
Yeah. Okay. And it takes in the header hash as well.
So it'll take the header hash and in this particular RPC call to Bitcoin D, there's also another parameter about verbosity. And this allows us to get, say, I forget how exactly they're defined, but there's ways to get the full block in a serialized, a serialized representation, or a more expanded representation, and may include some data that you may or may not need. For this particular example, if we do verbosity 0, I can't recall what this will return, but I'll look it up while you do that.
So run that by me again. I got a bit confused there. So the verbosity is a parameter that we need to pass in.
Yeah, so it's going to be a second parameter. So right now we have a slice of parameters where one of them is a header hash, but we want a second one. So since that's essentially a list, you could add another one here. And the verbosity will be an integer. And
it has to be a string as well.
So for this one, this macro, this JSON, the sturdy JSON macro that we used previously, we could use that again, and just wrap, use that to wrap a integer 0.
And then an integer 0. Okay.
Yeah, just like that.
Oh, that makes sense to me. Okay. And that's the. Oh, I get what you're trying to say now. So that's the second parameter that represents verbosity, and it takes a number between 0 and.
I think it's 0, 1, and 2 are the
and
levels.
That just defines like how much additional output you want in the response. I think, if I remember.
I don't know if I have access to the chat, maybe, but I sent this. If someone could relay that, I put it in the private chat.
Let me see if I can pull this up.
I guess I'm not logged in. That's probably why.
Okay. Let me get my browser up. Where's my browser? Block. So yeah, this is essentially the method we're calling, and we're calling it with a block hash and verbosity, which takes a numeric optional default equals 1.
Yeah. So
for verbosity 0. Okay.
So
but it says it's optional. Is it optional? Yeah, it's optional.
It's optional. I believe we might be able to implement this without it, but I'm not positive. I think our implementation that we're sort of delegating to this RPC client's call method, it might be smart enough to convert with any of these formats, if I recall when we wrote this. So yeah, 0 basically gives you a serialized text encoded version of this block. So it's very compact versus the more verbose versions of a JSON representation, or a JSON representation with I think it has all transactions in it.
Right.
So those are just different options we could use to return this block from our Bitcoin node.
Got you. Okay, and then finally, the get best block is going to be very similar, I guess.
I believe this one doesn't have any parameters, since it's just going to return us what it knows.
Best block and doesn't have any parameters. Okay.
Yeah, so this one, I think this is implemented slightly different in that So if we go to the docs that you had up there for the Bitcoin developer guide, and I think if we click on, let's see. Trying to think
So
where
if
this would be
you
in
do a
here.
search, get best block.
Yeah, if I remember correctly, this, so get best block hash. I guess there's a few ways of doing this.
Is that the same thing? Get best block hash and get best block.
Oh, that's the best block hash, which I think is what we want, right? Oh, you know what? Let's look at our interface again. So we're given, we wanted to return both a block hash and optionally a height. So the way this is actually, I believe, implemented in our implementation is if we use get blockchain info instead of that will give us all the information we need. And one thing we didn't really touch on too closely is that this call method, it is parameterized type. And so this one, there's some magic going on behind the scenes here. Like Rust knows that the return type has this pair, this tuple of a block hash and an optional height as its return value. So it's smart enough to call smart enough to know that this call method that we have here, we want the version that essentially returns us that. And the one that will do that is something that is parameterized by something that will take something that gives us this blockchain info data structure and do all the sort of the type conversion there. So I don't know.
Yeah, there's a good comment. There's a good comment.
End.
Yeah, there's a good comment here as well. Like you could simplify all of this by just using the Bitcoin Core RPC crate, which is a great point. We're kind of just showing how you might go about doing like a manually, but definitely
that's a good point.
Probably,
and
you probably don't need to do.
And I think we wanted to. I forgot if there was something with async there. I can't recall exactly, but at some point we would want to sort of use that or leverage it in some manner or combine these and sort of reduce this duplication of code we have across the rest of Bitcoin world and the LDK world.
So I'm getting an error here. Hold on.
So
this function takes 2 arguments. Okay.
Yeah, so now we need like an empty set of parameters here. So this is where you have an empty slice essentially. So if you put a ampersand before that to make it a reference. Okay. There we go. What else do we have? Oh, you know what? I think you want to remove the semicolon at the end there.
Oh yeah.
That's the nice thing about Rust is like it's sort of expressions.
Okay, cool. All right. So just to recap this then. So yeah, so we have these this implementation that we've kind of implemented ourselves, but there's a number of different ways that you could use, such as like the Bitcoin Core RPC crate to do all of this implementation. But the idea is that like it's completely custom and you can do like lots of different things within here. Okay, cool. So just in the thinking of time as well, how do we start listening for like stuff to get this information? Are we able to jump into that now? Is there still some like setup required?
Yeah, so I think what we'll do is we'll look at the SPV client that we define, or that's defined in the Lightning block sync crate.
Okay, let me.
So you might have to modify that.
All right. Oh, okay. So this SPV client here, yeah.
Yeah. So we have SPV client, and this thing takes a few things. It takes this validated block cutter, which we'll ignore for now. It takes a chain poller, which is something that implements the poll trait, which is something we'll jump into shortly. It takes a header cache, which we just use, I believe, a hash map for this, and a chain listener. So this is where we'll define some listener that reacts to these particular blocks. And this is something that implements the chain listen trait, which is from the Lightning crate. So not to get into too much details, but the the polar is something that this is something that will wrap your block source. It will call it as it's needed. This layer of abstraction we have here is to allow to have potentially multiple block sources that you want to sort of pull from and have sort of custom logic and saying, hey, let's prefer this block source. But if it returns an error, if it can't find this block, let's fall back to another one. So that will allow you to do that. So we want to for this example, we'll just have a single chain polar that wraps our block source. So this crate defines a chain polar, and so if you go back one, actually go back a couple. Let's refresh. Oh, there we go. Okay, so there's this poll module, and it says adapters that make one or more block source simpler to pull for a new chain tip. So this crate defines a chain polar for you. This wraps a single block source. So we want to create one of these that wraps the block source that we created. So we want to, I guess, create both of them. We want to create this, which if we look at the new function there, it takes a block source and it also takes a network. So if we're using reg test for this example, we're going to pass that. So yeah, that's how we go about doing that.
Okay. Is this something we can just do directly in our main, or?
Yep. Yeah, let's do the main.
Okay. All right. Walk me through this then. So.
All right. So first thing we probably need to import that chain polar that we had. So.
All right. So I'm gonna nick it from.
Yeah.
Yeah. So I'll just go.
And then so if you chop off, there'll be poll is the module, lowercase, and then chain polar is, there we go. And so we want to create one of these so chain polar : new.
Yeah.
And if your autocomplete shows up, it will show you the block source.
Block source, which was our this basically our Bitcoin D client.
Yep. So we want to create one of those. And I think so. Right now we have if you just create that, we have a we didn't define a constructor, but it is a struct that has a bunch of fields in it that we need to fill in. I would say for the sake of expediency, we could just comment out those fields and pretend they exist.
Okay. So do we need to create an instance of that first?
Either first or inline there. It's up to you how you want to do it. You can make a local variable. That's probably the easiest way. So you say let client equals Bitcoin D client. And you may have to import that as well, since it's probably Bitcoin D client : Oh, sorry, we got it. Very cool. And then since we didn't define any sort of function to construct this, we'll do it inline. So instead of parentheses, you'll use curly braces.
Oh, I got you. So,
and then you'll list all the fields that we had in there. And so you could say, like, if you go back to what it is, I can't recall all of them.
Yeah, I just cheated and just VS Code done it for me. So yeah, so we have an RPC client, which is.
So you have to create a new one of those as well. So actually,
Bitcoin client.
Yeah, and typically what you would do is you would define a new function that did some of this for you. So if we created a new function, it probably would create the Bitcoin D RPC client the RPC client for us and just populate that field, and we would pass the other variables. But we could do it just right here in line. So this is where an RPC client needs to be instantiated.
Got you. Okay, so.
Yeah, and if anything, since those take similar parameters, actually, sorry, that should be RPC client, not Bitcoin D client.
Oh yeah, I got you. Okay.
And I think that takes very similar parameters. For now, I would just put like empty strings for things that are strings and whatever else we have. So if you go to RPC clients, you'll see that.
Oh, so you mean it's like that?
Yeah, so it takes credentials. Like, so I would say just.
It takes like a host. Does it? If I highlight.
It takes two things. It takes an HTTP endpoint, which is sort of a helper that we have, in the.
So maybe
the
I actually need to
Lightning.
import. Let me. Oh,
Yeah, there's some few imports you'll need. So Lightning Block Sync has a HTTP module, which isn't showing up in the docs, but will be here since you have that feature enabled. So
okay, so basic auth is okay. This is what we looked at earlier. Okay.
yeah, so that you can just put an empty string for now. But look at the function below that. Sorry, if you go back, in the function below, there's a new. So you would say new. You would give it some credentials. We'll just use the empty string for that. And then the second parameter is the HTTP endpoint. So those are the two parameters we're going to use here.
Okay.
Yeah.
Okay. So credentials, and then the endpoint is just my local. Would it just be my local host?
It's like a sort of a host pair, host port pair rather.
Shall I put that in, or
there's a special type for this, so you're gonna have to import. So say use Lightning Block Sync on top.
Use Lightning Block Sync. Yeah.
Yeah. Then you want HTTP. So copy that part.
Yeah. Then I want HTTP.
It's gonna be, a lowercase HTTP, and then : HTTP endpoint. Oh, maybe it's not there. Let's see.
Is it HTTP client?
This might be a problem if we didn't.
No, I've got it. It's the endpoint, right? So HTTP.
Yeah. Oh,
endpoint.
there it is. Okay. Cool.
Yeah.
Cool. I was getting worried that we didn't make it public.
No, I think you're right. So it says is a private struct.
So it should be HTTP endpoint, not client.
Oh, endpoint.
But that one, HTTP endpoint. There it is.
Okay,
cool.
there we
got
go.
it.
There we go. Cool.
Yeah, and I have to remember how that one's constructed too. So that one probably has a new that takes. It has a element that says for host. I think if you use a save.
So is it this what I'm looking at here? So it takes a host, a port, and a path.
Yeah, but those are private. So look at the functions below it. It has this way of constructing things. So if you say for host and then you give it a string, and you could follow up with dot with port, you can give it another string. It allows you to sort of chain these calls together to construct an endpoint.
Let me just get rid of this because I've got like 101 parameters at the minute. So let me get rid of some of this.
Yeah, and we're going to actually remove those parameters since they're duplicates. But yeah, let's make a new variable for the endpoint.
Okay, so endpoint.
Yeah, so do HTTP endpoint.
HTTP endpoint new.
Yeah, and I think so. It's not called new though. It's called for host, I believe. You go to for underscore host. Not sure why it's not popping up.
Oh, there we go. Okay.
There we go. Okay, and then you can just put in the string. You just put the empty string or localhost if you'd like for now. And then dot with port.
Yeah.
And then you put a port number. Once you
for
have
reg
that.
test. Yeah, I think it's for reg test. It's the 18433.
And then just end that with a semicolon. It should be enough.
Okay, so we define our endpoint. Cool.
So for endpoint, we'll pass that in to the endpoint parameter of RPC client.
Endpoint here.
There you go. All right, and then
someone just commented build a pattern, all the things. Yeah, I don't even know what that is. So
yeah, it's a nice way of chaining things.
Oh, okay, cool.
It's Duncan, I think, in chat. Yeah, so let's go back to our Bitcoin D client.
Our Bitcoin D client, yeah.
And so we actually don't need the host port RPC, all those, because they're essentially being passed along to the RPC client. For sake of time, we'll probably have to leave it to the users or the viewers rather to actually construct the parameters they need using the documentation for RPC clients. But for now, if we go back to main, we'll be able to complete this. So it has that one, and I think we just want to end it with a semicolon. Might be all we need for the client.
This is syntax error expected semicolon.
Just throw a semicolon. There's an extra. You can get rid of one of those.
Oh yeah, I've got one too many there. Yeah.
So now we have our client. We want to pass along that block source or something that references a block source. So I think if we for block source instead of you can just replace Bitcoin D client with I think it's ampersand client. I think should do the trick.
Ampersand client.
And then we would need our second parameter, which is the network, if you recall. So if you're using, we'll import that or just use that. Perfect. That's all you need there. And then end that with a semicolon. It might be a problem there. So let's just scroll over, see what the error is.
So the trait bound Bitcoin D client Bitcoin is not satisfied required by Lightning.
So we want to make it a mutable reference. So if you change let client to let mute client, you need both of these. I think you'll need.
Okay.
You need it there, and also I believe of the reference. So if you go to where it says ampersand client, you should turn that to ampersand mute client. It's a mutable reference.
Like that.
There you go.
Okay.
Yeah. All right, and then I think our last problem, we want to change this. I think
strings.
it's like for host, to string there. It looks like, or maybe it needs correct. Try a to string at the end, but because this is a string literal, which is just like a reference to the string. If you underscore to underscore string, there you go. Just happy about that. And then let's see what this one's complaining about.
Mismatch types.
So let's see. So creating this, it's going to return a result, and so we're just going to assume it's okay. So let's just put a question mark after the new, and that will return an error if it's a problem. Actually, not after the new itself. Rather, if you undo that, and then put it after the closing parenthesis of that new.
Okay. Yeah.
That should do it. And this might be because it's main. Let's see.
The question mark can only be used in the function that was turned result.
Yeah. So since main is not returning something, I think we could just say unwrap instead of the question mark, and let it be an exercise to the viewer to do correct error handling here. All right. What do we have? What's this?
Field Bitcoin D RPC client obstruct.
That's probably private, right? Yeah. So let's just make it pub. Let's just make it pub. If you go to Bitcoin D client.rs, we'll just throw a pub in front of that. There we go. All right. I think this will at least build, and we're getting there.
All right, we're nearly there. We've gone around. Still, glad you're still with us. How are we doing? So we've got can cookie. All right, here's a question. Can cookie-based auth also be used with RPC client here?
That's a good question. I believe so. I'd have to look at the RPC client's constructor and see what it allows. It's been a little while since I've looked at this.
Okay.
I don't know if you want to open that up and we could answer that question.
We've not got too long. We've got 5-10 minutes to go.
Okay. It's
we
basically some base 64 encoded credentials. If you could look at the docs for that, I think you could use base authentication, but I'm not positive about that.
I can just run it directly. So should we try and just run it just to see what happens? Or
it's not going to do too much, but I think compiling is fine for now. Let's see. Now that we have a chain polar, we're going to want to create this SPV client and pass it into that. So let's make that a local variable, this chain polar. So let's say let polar equals and what you have before that. You can just grab that, cut that, or put it before, whichever works best. And now we have our chain polar.
Cool.
And now we're going to make a SPV client. So let's say let SPV client equals, and we'll look at the docs to see what we need. Issue underscore or all lowercase SPV client, because it'll be we want a variable first.
SPV client.
and then equals SBV client new, which you may have to import as well. So it's going to be under Lightning Block Sync, and it'll be a top level struct. So Lightning Block Sync : I would import it, and I think it's probably, let's see if it's lowercase or uppercase.
I don't know why sometimes VS Code auto imports and sometimes it doesn't. But anyway, SPV client. Is it just the whole? Sure.
Yeah, I think it's underscore for the PV, but I'm going to check on that.
SPV underscore client. Oh, let's have a look at the
no, sorry. Yeah, it'll be SPV client where the P and the V are lowercase, but everything's one word. There we go. And then so colon there, and then use that same name, SPV client,
okay.
colon new.
Yeah.
And from that, let's see. Find the docs.
Okay, so creates a new SPV client using chain tip as the best known tip. Takes to instantiate it, it takes a chain tip of the validated block header, a chain polar, a header cache, and a chain listener. Okay.
All right. So we have, let's see if we can find that. So we have our polar. Now we want to get a validated tip, which I believe since we don't have one, we could get that in a different manner. So Lightning Block Sync has an init module. So I think we had the docs up at one point on that, but there should be a way to get one for basically a new chain. So I'm going to look those up myself.
Okay, while you do that, there's a question. Is HTTP endpoint where the Bitcoin node is running? Yes. If if I wanted to experiment with LDK and my Umbro node, is the HTTP endpoint where I would configure that?
Yeah, that's exactly
I think the
right.
answer is yes to both of those. Yeah.
You would have to be able to reference it with, I'm not sure how Umbrella works exactly on your network, but having either a IP address or a host should be compatible with that. But yeah, I'm happy to take questions offline too. So if anyone wants to jump on the LDK Slack or Discord, I'll be there and would happy to walk you through anything if you run into trouble.
Okay, so yeah, so we need to instantiate. Sorry, we need to instantiate this SPV client. So you were just checking was it the chain tip you were?
Yeah, so there's a module under Lightning Block Sync called init. So Lightning Block, you want to import this, use init. Yeah, and from there's this validated best block header. That method, essentially, you give it a block source, it will return you what it thinks is the best header. So it's nicely utility to use for that particular parameter.
So if I did this, use Lightning Block Sync init validate.
Yep, that'll work.
Block header, and I pass
that. You could call that
first. And then pass in our block source, which is.
So it looks like you want a mutable reference. I think, yeah. So ampersand mute block source. So I would actually, now that I think of this, you want to do this separately from this. Instead of doing it inside the parameters here, I would do it before you have the polar. So before that polar equals, you would want to get it from there, since you could only have one mutable reference at a time in Rust. So I'd say, let's header equals, and then that call.
But does this need to be mutable as well?
No, that's okay how it is.
Okay. And then this is equal to the validate best block header.
Yeah, and you're going to pass in a mutable reference. So ampersand mute, just like you did with the client. Yeah, there you go. So that'll give us that, and then we could pass that header in the second parameter first parameter to the new there. Our second parameter will be our polar, so we want to pass in the polar there. I don't recall if it's a reference to one or just takes it by value.
I think it looks like it just takes it by value.
Okay, so it's going to take ownership.
Actually, no, it says no, mutable Bitcoin D client.
Oh, so it is by value, but it's referencing. That's fine. I think you have it right.
Okay.
So, and then the third parameter, what was that one again?
I hate the way VS Code is just like
I'll look it up. It's okay.
Formatting things for me here, but never mind.
It's having large displays.
yeah, I know, right? All right, so sorry, you got a header, upload. The third parameter was
the third parameter, I believe, is some sort of cache that we want, if I recall.
Header cache. Okay, header cache.
Oh, there's actually 4 parameters. Yeah, so this one, I would do is prior to this, or you could just say, let me see if it's a reference or not. If it's a reference to a cache, so I would make a new variable before this, just like you did with polar, and say, make sure to put a semicolon at the end of polar after you're done too. But you could say let cache equals hash map : new. So
okay.
I think that will work. Otherwise, I think we actually defined.
We need to pass any parameters to this as well. Cache new.
It should be good, I think. Or sorry, no, it should be hash map instead of cache.
New, and then inside the cache.
Sorry, instead of cache, put hash map.
Oh, okay. Hash.
This will be the Rust hash map type.
Oh, okay.
And so I'm not sure if you have to import anything with this. Let me double check.
Yeah, I think it's from collection.
STD, yeah. We defined a type in yeah, you know what? You could either use
so I just imported the ones. Yeah, I imported the one from collections. Yeah.
Perfect. Yeah, we make a type alias for this called unbounded cache, but that will work just as well.
Okay.
And so we have our cache, and we got everything except our listener. So it looks like we want a mutable reference to that cache, I believe.
So let's. Well, when you're referencing, you just give it an ampersand, right?
Ampersand, then the word mute after that if you want a mutable reference. And yeah, it could. I think I'm not sure if it needs a space there or not, or if it cares, but yeah, it should just throw.
Yeah.
It doesn't matter either way. And then our last parameter is our listener. So this kind of gets us back full circle. What we started talking about before is that we want this data that we're pulling with this SVB client. We're pulling our block source, and it's doing all the hard work for us. It's telling us, okay, hey, this is maybe there's a reorg, so I'm going to disconnect some block, connect some blocks, and it's just going to call those methods on the listener. And in the realm of Lightning and LDK, we have a couple of listeners that are sort of permanent. So if you go through that guide we have on our website that I think we linked some of the tweets. This guy here, you'll see that it talks about this channel manager. If you go back one there's channel managers and this chain monitor. These are both types of listeners. They implement this chain : listen trait, which is defined in Rust Lightning, the Lightning crate of Rust Lightning. So the one that this Lightning block sync depends on. And so we're not going to use those in this particular example. We'll define our own. So if people are okay with us going over a little bit, we could probably finish this up pretty quickly. If you want to go to let's go to the Rust document, the Rust Lightning documentation. Yeah, so here, if you go to the chain module, and then you go to, we have these traits listed on the bottom of this listen trait. And so if you click on listen, it's at the bottom of the page. Here it is. So you have block connected and block disconnected. So these are the methods that will be called on your listener that you pass to the SVB client. So the SVB client queries your block sources. In this case, we have one source. Hopefully my headphones didn't die yet. And from that, it will pass along that block information to your listener. So we can define a listener that implements these two methods.
Cool. Okay, let's quickly do that. We'll go for 5 more minutes, guys, and then we'll call it a day and give you some homework to kind of finish it off. So we're gonna define a listener. Okay.
Yeah. So we'll define a struct. basically. We're going to do this outside of main. We could do it in the same file. We'll define a struct. We just call it listener. And it's just it's not gonna have anything in it. So you just could press, yeah, this can be empty. And then we'll say, we want to implement this trait for that listener. So we're gonna say, you know, impl chain colon listen. This is actually lowercase. It's going to be actually part of the lightning crate. So if you say instead impl lightning colon chain colon listen, we'll just do it right in line instead of importing. So lightning colon chain colon listen. Should we just listen? I'm not sure if that's for okay. And say for our listener.
Yeah.
And from there, if you probably just copy and paste those two methods that we had mentioned.
Yeah.
And then we'll have to define them. So make those open parentheses. And those are, yeah, block. Oh yeah, we imported those in the other file. That's right. So let's import those again. And then we could just do some prints there. You know, just print ln.
What is it? Print n. It's in Rust.
Print ln exclamation point. Yeah, that's the macro in Rust. And from that, I mean, you could do these formatting specifiers, but let's just give the, you know, if we give the hash or the height, but yeah, you could say block kind for now. We'll let the users or the viewers rather.
Well, we could do so. It would be like something like this, like block and then dot height. Was it?
You could get, or the height is a second parameter that's given there, but yeah, you give. I think you could do like block dot block hash. I believe what it is.
Block hash
underscore hash. Yeah, there it is.
Okay.
And then we could do the same thing with the disconnected block there. All right, and then disconnected. And it doesn't take a block, but it's a header. So you have to turn that to a header, which also has a block hash. So just rename that. Cool. And now if we construct one of these listeners in our main, we could pass it in as the listener will be I believe it'll be a reference to a listener.
Okay, so let's call it let listener. Oop. And that's going to be equal to listener.
Just listener. There's no functions defined yet. So if you just say listener, and then I don't even know if you need the parentheses, but or the curly braces, but you just put a colon after that. See if that works. Or semicolon. Like sorry. Yeah. Try to put two braces before that, before the semicolon.
Oh yeah.
Let's see if that works. Okay, and then our last parameter will be a reference to that listener, which I believe doesn't have to be mutable. Yeah, it's a regular reference. And then you could just throw a semicolon there. And this SPV client, it has a poll best tip asynchronous function, which would be sort of run in a loop essentially to do the polling or do asynchronously on another thread. But this is essentially kind of how things would work. What else do we have here? There's an error.
So we've got an error on the header. Mismatch types. Expected validated block header found future.
Could you? Oh, okay. So we have to actually, if you go back, we want to await on that header call. So we call validate best block header. This lightning block sync crate is very asynchronous library. So and then I believe, yeah, if you do, or if you just say unwrap for now, this would be kind of going away with error handling. We'll just assume it worked. And let's see.
So do I need to unwrap first and then await, or?
Let's see what it says. If you scroll over that.
Oh, it's because our main is not an async block, yeah.
I see. Yeah, there's some more setup we need for this to sort of work with that. I think it's actually just a attribute you sort of add on to main to do this. So if it's in like our lightning block sync crate, we may have to import a few things to get this to work correctly, like from Tokyo.
Okay, all right. If that's the case, then we'll pause there. We didn't get quite to being able to like print out so ideally we wanted to be able to the next stage was to basically just spin up our Bitcoin D instance, mine some blocks, and then that essentially will print out a block hash. But we have run out a bit of the time, so that's your guys' homework for this week then, to like kind of complete this and see if you can listen for the events that would happen when you mine a few blocks on your local instance, and see if you can get the result. In this case, it's just the block hashes, and let us know how you get on. Did you have any other things you wanted to touch on just quickly before like maybe we answer a few questions if there are any?
Yeah, so I guess I'm not sure if there's any comments in the chat. Tokyo main, I posted, if you could relay from the private chat, I posted what needs to be added to the main function for that. And you would probably need some dependencies on Tokyo. If you're really interested in, if you're struggling in getting this to work, there is a Lightning Dev Kit under that org and GitHub. We have a sample app called LDK Sample, and this
let me get that
essentially
up, actually.
will allow you to kind of cheat a little bit and get this working.
So that's
so that'd be one thing you would need to do, and then getting the credentials, all that endpoint HTTP endpoint hooked up correctly, and you could you crib off of this if you'd like, and see how it's sort of calling that one method. What do we call it? There's like chain or pull best tip, I believe.
Yes.
SPV client has one more method called pull best tip. Yep. And so you can see how that's using it. And once you get it all connected, you should see in your console all the new block hashes as they come.
Cool. All right, that's really cool. We didn't get quite around to finish it. Like I'm trying to keep these like quite short, no more than 90 minutes. So we're definitely not gonna get and we're live coding, which is not always the easiest. But we
deliberately did not prepare.
yeah. I kind of go into this with kind of very little preparation, and because the purpose is to kind of talk through as much of what we're doing as possible, and then you guys go away and like delve a bit deeper into certain aspects of it. Okay, appreciate it. Thanks for the stream. Need more. Yeah, if I can rack my brain around Rust, I'll try and up it to twice a week, but I think 90 minutes a week is enough for me at the moment. And to be fair, like I want this to be a community-based platform. So if any of you like want to stream during the week, like please let me know, and like we can organize something where maybe you guys host a session with someone else, and you learn, and we learn stuff together. So any kind of final thoughts for the viewers, Jeff? Like where can they I guess where can they find where to communicate with like other project contributors, like Slack channels, all that kind of stuff?
Yeah, so we have both a Slack channel and a Discord channel. I believe there are at least links to the Slack channel currently on the website on lightningdevkit.org. And if we don't have a Discord one up yet, you could find it in the Slack itself. We just opened it up yesterday. And so, yeah, plenty of us are there. Happy to take questions if you have anything, if you're trying to work through some of your problems here. Rust is definitely a really cool language that takes a bit to learn, but once you get there and you start understanding all the compilers, and you kind of appreciate it more. So don't give up on it, and also we'll have language bindings if you do. So this might take some time.
Yeah, and this was just like literally our first foray into doing LDK stuff. So we've got loads more coming. By that time, hopefully, I'll be a lot better at Rust and be able to type a lot quicker as well.
I didn't know any Rust until I started on this project. So it's been a couple of years, but it didn't take that long to come up to speed.
Yeah. So, and yeah, some of the other things that are coming in the pipelines as well is like Android mobile app examples with LDK, iOS Swift examples with LDK, potentially some browser-based stuff as well. And yeah, just continually diving deeper into the library and allowing you guys to know what's available. So yeah, I mean, if there's no other questions, we've gone a little bit over in the stream today, but if there's no other questions, we'll kind of leave it there, and I hope to see you guys again next week. And Jeff, thanks again for your time.
Yeah, it's been fun. See you, Connor.
Awesome. Peace.